Okay, so before I begin, I want to quickly go over the working fluids that are used in order to use engines. And before I do that, I need to talk to you a little bit about combustion. So what is combustion?
Burning.
Yes. Yes.
I believe the words the Black Eyed Peas. It's that boom, boom, boom.
Okay, so what is combustion? Combustion is the process by which a fuel is oxidized and energy is released. In other words, it is a process by which fuel is burned in the presence of an oxidizer. Components before the reaction are called reactants, and components after the chemical reaction are called products. So for example, in the reaction, H2 plus O2 gives you H2O. These are called reactants, and this is called the product. Is this reaction allowed? So how do we balance it? I don't like the 1/2 type kind. Yes. I've never liked the concept of putting a half. I like
whole numbers are so much better.
Right? I agree. So I usually end up doing that. So what is the most common oxidizer? Regular air. Which is approximately 78% nitrogen, 21% oxygen, and plus other things. And Andy, you're right. So we do use oxygen in processes like welding and cutting, which means that for every 1 mole of oxygen that enters the combustion chamber, 0.79 divided by 0.21, or 3.76 moles of nitrogen enter with it. Enters with it? Okay. Another thing to keep in mind is, why is it important that we have nitrogen in our system. In a lot of cases, nitrogen is very useful because it absorbs a large amount of chemical energy released in the process. Other than that, nitrogen totally behaves like an inert gas. Do we all know what an inert gas is? That it doesn't react with other things. So, other than that, it behaves as a inert gas. So for mechanical engineers, you will hear this term. It's called air-fuel ratio. Also AF ratio. And that is mass of air divided by mass of fuel, given by M, air, divided by M of the fuel you're trying to use. I'll put this one in a box. I want to tell you something else. Now, this is going to be a little bit strange, but I want you to change the color of the one that you're writing with, because this is kind of important. Remember, the number of atoms in a combustion process or in a chemical reaction must be conserved. However, the total mole numbers may not be. Which means that for our air-fuel ratio, we also have to define it in terms of the mole numbers of air. So the AF ratio can also, the AF ratio is also written as mole number of air divided by mole number of fuel. And in fact, it is written as M air divided by sum of the NI/MI of the fuel. Everybody understands what this sum means? So let's say you had more than one fuel, 2, 3, 5. What would this become? Anybody want to hazard a guess? What will this become? N1, M1 plus N2, M2 plus N3, M3. Sum. So you have to take into account every single fuel that's in your system. Where N is what? The number of moles. Of fill in the blank. Air, fuel, fuel 1, fuel 2, fuel 3, whatever it may be, right? Remember, what is a mole? Of whatever you're looking at. Avogadro numbers of snails, Avogadro number of ants, Avogadro number of planets, Avogadro numbers of molecules, moles, whatever it might be. Atoms.